In this video, we're going to learn how to find the inverse Laplace transform of this special one. And you can see here, there's a problem. So if you look at the denominator, and it is not easy to factor. But if you can factor, then you know how to do it. You like the partial fractions. But here you cannot do that. So since you cannot do that, the next thing we're going to try is we see whether we can write the denominator as a complete square. So that is the argument we use. We use the completing square technique. So let's start with that. So what we're going to do, we're going to start with the denominator, just the denominator. And then we're going to see whether we can rewrite this one as a complete square. So the idea is, so if you see a number in front, what you're going to do, you're going to factor that out first. So we can write this one as 2 and write the leftovers. And you can see, so we have s squared. And then if you take 2 from the second term, you also get minus 2s. And then we leave a space and write the other number outside. So that's what we do first. That's the first step. The second step, we're going to find half of the coefficient of this term. So half means -1. And then what you do, we square that number. So when you square -1, and you know that it is going to be 1. So what we do, we're going to add 1 first inside. So we're going to add 1 here. But when you add 1, what will happen? It actually add 2 because you still multiply by 2 outside. So that means when you add 2, when you add 1, you add actually 2. So to match the equation, what we do, we're going to subtract 2 from the equation, because when you add 1, it actually add 2. So to match that, so you're going to subtract 2. So that's what you get. And then when you do that, what will happen? We know this formula. So when you have a minus b squared, which is going to give you a squared minus 2ab plus b squared. So that's the formula we use here. So you can see, what is inside here, what is inside there is the half of the coefficient. You have to write just half of the coefficient. So we can use the same idea here. Now, because of this formula, you can write automatically the inside term going to be s minus just the half of the coefficient, which is 1 and squared. So you can always write it. It's always the case when you do it like that. So s minus squared is minus 1 squared. And then we have outside you only have 1. So that is the complete factorization of the denominator. Now what we do, after we do that, we're going to go back to the fraction and we can write it like this now. So the fraction you can write as, so numerator no change. For the denominator, what we can do is we can write this one now. So it is 2 s minus 1 squared plus 1. So that's what you get. So that's the first step. So next what we do, we have this half factor. So we're going to completely take it out of this whole fraction. So we can write this one as 1/2. If you take out 1/2, so what will happen is inside s plus 1 stays there. And here what will happen? The first term going to be s minus 1 squared. And since you pull 1/2 out, you get 1/2 as a fraction. So that's the next step. You pull the 1/2 out. And then third step is we can split this fraction into 2 parts. So next what we can do, we still have 1/2 out. Now we can split them, one with the s term. Actually, before we do that, we try to do something else here. You see that the numerator is not just s, it is s minus 1. Since it is s minus 1, you try to recreate s minus 1 in the numerator as well. So what we do, we write this one as s minus 1. So when it is minus 1, since you subtract 1, you have to add 1. So it's going to be plus 2, not plus 1, plus 2, because you subtract 1 and add 1. So you do that. Now you can see it is s minus 1 squared plus 1/2. So the next step is we can split this into 2 fractions. So you can write this one as 2 fractions. So the first one is like this. and the second one is going to be, and you can see 1/2 and 2 get cancelled, so you get this. Now let's try to recall some of the formulas that we have, because like you can see that there is a s minus 1 term, so that means you need the first shifting property, and also you need to look at what other forms that we have. So we have these formulas. So this is what we normally call the first shifting property, and then we have these sine and cosine formulas. So we have the Laplace transform e to the minus at ft is fs plus a with the opposite sign, and then we also have the cosine which comes with the s, and the sine which comes with omega. So now we're gonna match what we have with these two. So we have this now. So because of the linearity of the inverse function, inverse Laplace transform, we can write it like that. So we can break it like 2 like that. And then you can see in the first one actually these two terms match. So that means you can, this is close to the cosine transform. But when you look at the other one, and you can see that you have a 1/2 here, but you don't have the term in the numerator, because 1/2 means you can see it is 1 over square root 2 squared. So what we do, we're gonna put that missing term up there. So we're gonna write that term, which is 1 over square root 2, and we also divide by the same term so that they cancel out each other. Now you can see everything match. So what we're gonna do now, we're gonna use the first shifting property. So according to the first shifting property, what we're gonna do, we're gonna figure out what is the form first. So you can see that the first one is the cosine. So this is the cosine 1 over square root 2t, and the next one you can see sine 1 over square root 2t. But there is a s minus 1 term. What s minus 1 term does is the shifting. So in this case, since s minus 1, what you want to do is a equal -1 in this case. A equal -1. So we're going to plug in -1 into the formula now. So we can write this as a multiplication with the exponential term. So that comes later. So we can write this one as now 1/2. Because of the shifting, you get e to the t because a equal 1, and then you get the cosine term, cosine 1 over square root 2t. So that's the first one. The second one, you can see we have 1 over square root 2t in as a multiplication, and because of the s minus 1 term, you get e to the t, and then you get the sine 1 over square root 2t. So that is how you transform a problem like this. And then you can see that first you need to figure out what is the right format. So what we did here, we use the partial fraction, we use the completing square first, and then you write the denominator as a complete square, and then we can split them, and then we try to recreate the same term in the denominator. Since we have s minus 1, you try to recreate the s minus 1 first, and then we split, and then we try to match the terms. So what happened at the end, you can see that for the sine term, you try to get the same term in the numerator and the denominator, so you get 1 over square root 2 there and also there, so that they cancel each other. And then we write the form. First we figure out what is the right form. So since the first one is a cosine, we write the cosine, but because the s minus 1 term, we have that extra term coming out. Same thing with the other one, you have the extra term coming out. So this is how we do a problem like that. Now we can try these two as practice problems. Now try these as practice problems, and you can see you can follow the same very similar argument, and you get a plus term here because the plus, and then this is also very similar to the previous problem, and then you can see that you get fractions here because of this, the format of this one. When you try to do that, you get some fractions, and the next one actually here you can see because the plus 3 term, you actually get a negative here. So because of that, your answer will be not sine cosine, it will be hyperbolic sine cosine. So you get the sin and cos for the last one. Sin and cos. Okay, so you can try them and you can match the answers in the description. So thank you.